hear me through the Teams app? Okay, excellent. So today the agenda is fairly brief. We're just going to cover some best practices. And did you know, basically, I just ran through as much of SQL Server as I could think of and a collection of tips and tricks based on my experience of working with SQL Server. To give a little more context to my current environment, for the last 5 years, I've been working for a large student transportation organization. Think of Lyft, but for students, much more scheduled. As a result of that, my workload is heavily transactional. So OLTP is a primary workload, which call it 5,000 mobile devices pinging their GPS locations every 45 seconds. That type of transactional workload, along with all distributed systems that talk to that system. So when I say make a SQL Server go faster, I have to make it go faster. So with that, let's go on. The first thing I like to do is, of course, tips and tricks. How do you configure your SQL servers? This is some of this is going to be obvious stuff. If you're here, it's because you want to learn. So you probably already know a lot of this stuff, but I hope that you will learn something new, at least one thing new. Temp DBs, you should have at least one file per CPU core up to 16. After that, the payoff starts dropping fast. Of course, everybody's environment is completely different. If you find something that works better for your environment, you should change it, but you should test. But these are best practices, places to start. Max memory for your server. I work in Azure managed instances, so all of this is managed for me. But when I worked in an on-prem environment, this was my rules of thumb for how to set my max memory, which was leave stuff for the OS and any ancillary applications that run on the same server. For example, if you have your web application running on the same server as a SQL server, you need to reserve memory for that. If your reporting services also runs on that, then same. So if you stack everything on your SQL server, you can easily get to a server that has 32 gigs of RAM, and you've only got 4 gigs for SQL to run because you need to leave space for everything else. But no one's doing that. CPU licenses for SQL Server are your most expensive license. You shouldn't crunch everything down just to save a few dollars. More memory makes up for a lot of sins. So if your performance is suffering, especially if you have an on-prem machine, for a few $1,000s, you can max out that server as much memory as you can throw at it, and that'll make up for a lot of problems. If your entire database lives in RAM, then there's no disk access, which is the slowest part. Maximum degrees of parallelism, the number of cores up to 8. After that, unless you're running analysis services, letting a single query burn more than 8 cores, it spends more time coordinating that effort than actually doing any work. So just minimize that. Cost threshold for parallelism, I usually set it to 50. This number is still far too low. Given the speed of modern processors and their single-threaded performance rate, 50 is too low. But I don't know of a good starting point. It's better than the 5 that it starts with, though. Play with this number in your environment to see what helps or doesn't help. I found better success. Most of my queries are single-threaded by their nature, by the way they work, transactional, so they go one key value at a time. So when I have a query that I need to tune, I usually just add a hint, max stop 1, to the query itself to force it to go single-threaded. And that usually fixes my problem queries for the most part. All right, so tables. Heaps are just terrible. Not terrible. There's always, anytime there's a rule of thumb, there's an exception that needs to be made for it. I'm going to stop saying that because it is just evidently true. However, heaps, for the most part, you don't need a heap. Even if you don't have a good primary key or a good unique key, make one. If you don't make one, you get one behind the scenes. Especially if you're going to be deleting records out of your table. you need a clustered key. Without a clustered key, your heap, when you delete a row out of a heap, it doesn't go away. It's a ghost. It lives in the data, lives in your pages forever until the table is rebuilt. So if you trunk and load your table, then heaps are okay. You can survive using that if you need to speed up your load that much. But for the most part, just throw some key on it and let that be your primary key. Large object binaries, things like XML data types and var binary maxes and nvarchar maxes, you should really keep those to a minimum. I have one table in my environment that the minimum row size exceeds 8 kilobytes, just because it has something like 5 or 6 XML blob columns on it and just stacks there. This is extremely bad for us because this is also one of our busiest tables. It gets updated constantly. It gets read from constantly. It drives our business. But this table is enormous. The side effect of having large blobs sitting on this is that it wants to keep this table in memory. It eats a lot of RAM just keeping this table in memory because it has to keep all of these blobs that are only accessed at the beginning and the end of our processing. So the solution for that is to break your table up into pieces. I would have advocated during the design phase, I inherited this table. I would have advocated for all of the large blobby columns to go into another table, an ancillary table for this one, and keep the meat and potatoes transactional data, state level data in its own table for speed, if nothing else. But it also would really help with our page life expectancy and how much memory we need to keep our SQL Server running efficiently, which in the cloud equals dollars, significant dollars. I'm not CPU bound, but I have to buy enough CPUs to have enough memory to drive the system effectively. If I could come to my business and say you can cut the cores in half, they would love it. It'd save them $3,000 a month easily. Next thing, pet peeve is to name your constraints, your defaults, your keys. If you use if you use source control for your database, which I hope everybody is, for your database objects, if you don't name the constraints in source control, then the system will name them. And then every time you deploy, it generates a new system unique name, drops the object, recreates the object constantly. So this is your benefit to naming them. Also, it helps a lot when you get an error message. It tells you the name of the constraint that's violated. If you can just look at the name, then you're like, oh, it's this table, this column, this schema. I have an idea already what the problem is. Table partitioning. I know there's a presentation coming up on table partitioning. I'm really looking forward to it. For me, I've seen a lot of benefit with maintenance on my tables, not so much performance of my queries. I know you can get it, again, certain environments, you can see that. But for the most part, I use partitioning to quickly add and drop logging partitions. So I'll have my partitions arranged by date. I'll have a day's worth of logs. And then in 14 months, I just drop that partition, which is great for managing large logs. Yes?
So is this specific to
I would apply the partitioning to any, whether you're on-prem or cloud. I'm using managed instances for mine, which are almost feature complete with any on-prem server, with the exception that I can't see some like full text daemons. I can't see that as a separate process. I also don't have control over the underlying structure, compute resources. But the advice I'm giving here is fairly broad. I would apply it to everything. Computed columns. I don't know if anybody is using computed columns. We do quite a bit. The piece of advice I have for that is to always make them persisted, define explicitly their nullable status or not nullable, and then to control your data type. A lot of times you'll see persisted columns. Somebody will put a hash for hashing various columns there. If you don't explicitly convert the output of hash bytes to the correct data size, you end up with a var binary max at that. So for example, if you're hashing your columns using SHA-512, I think that's 64 bytes worth of data. but unless you explicitly can convert that output to var binary 64, you get a var binary max as the output. So you're spending a lot of storage, potential storage on your system. But by making them persistent, the values only change. It only gets recomputed when an underlying value changes. So your CPU is fairly cheap, or disk is cheap, CPU is expensive. And the next thing is to consider your insert, update, delete, and select behavior. What are your most common things? If your table is write once, read never, whatever, throw everything into it, just insert into it and forget it. But if you're constantly coming back and you're updating and you're doing this, you need to think about that. Decide, does it make more sense to break out my large binary objects into their own table? Is there this piece of data that constantly changing status or estimated arrival times? Do I really need to store that on the table? Can I better make better performance by making a child table where that gets streamed into it, and then we look that up when we need to? Yes.
So if there is something like you have to be the entire table, or
oh yes, I would explicitly make an identity column for that. Where there needs to be an integer or a big int, just stay away from GUIDs unless you absolutely have to use them.
is there any that's always ever growing? It's always on the last page.
Modern SQL Server has optimized that for if you're inserting, that's no longer a hotspot. Yeah, not anymore. I think 2016 onwards, they changed how that behavior. So rapid fire inserts are no longer a hot, you don't have to worry about that hot page anymore.
Sorry.
Mhm.
Naming constraints defaults, just talking about defaults for a column
Mhm.
and not naming them, right?
Yeah, so if you have a column and you create your table and you just say default and you don't specify a name, you just say default current date, for example. Under the hood, the system will create a default called df and then some string of numbers and letters after, and it'll call it that. And that's fine if you've only ever created the table in Management Studio and you never touch it again. But if you have your stuff in source control and you write your table definition that way, then source control will come along and say, well, what's the name of this constraint? The user didn't name it. I'm going to name it custom. I'm going to name it df and random string of numbers and letters. And like, this constraint needs to be dropped. I'm going to create this new one. Default constraints don't have much of a performance penalty to drop them and recreate them like that. But if you have a check constraint that you've not named, now you've got to drop the check constraint and then add it and then check the data, unless you're going to go with untrusted check constraints, which I would argue are pointless. Yeah.
Usually I take the lazy route. I just write the column. When I define the table itself, I have a column name and then just
Okay. So when you're deploying that, it just, if you look at sys.constraints, it'll just have df and such. And if you ever look at deployment, so if you deploy your schema on top, you like update the schema, that's always in there. It's always having to drop that constraint and then re-add it back. Because you've not named it yourself, you're letting the system name it. It names it differently every time the model runs. Yeah. So SQL Server indexes. Whenever we're interviewing someone, I always like to ask them to rattle off the names of all the types of indexes you can have in SQL Server. It's never a gotcha thing. It's always trying to figure out where the depths of their knowledge are. Yeah.
Finally, because I got asked that question.
Yeah. But if they can't name the typical ones, that's again, that's a cliff that's too close to, uselessness. So these are the ones I expect candidates to know, which is of course clustered indexes, which is your table. Heaps, I guess, could be called a type of index. They do appear in sys.indexes, but it's just a raw table, unstructured. Non-clustered indexes, unique indexes, which are really a subset of non-clustered indexes. Full text indexes, which really don't exist in sys.indexes. They're a totally separate thing again. And then filtered indexes, which are great when they're used properly and you can convince the engine to use your filtered index. That's the tricky part. That's where it starts getting tricky.
Yeah.
Sure. Oh, certainly.
So non-clustered and unique, what is best practice? Normally what I do is non-clustered, and if I need it to be unique, I set that ignore duplicate off.
Mm-hmm.
So it's unique. That's the best practice that you have been doing.
So the question was about whether you should use the allow duplicate keys option when you create a non-clustered index, or whether you should specify unique in the name of the non-clustered when you're defining create unique non-clustered index. I would prefer to go with the create unique non-clustered index. I would have to look it up. I think that when the allow duplicate controls how nulls are counted as duplicates or not duplicates. I may be wrong on that. I would need to look it up. I think that's what that controls. I would drop the index and then recreate it as create unique non-clustered index, is what I would do.
And if the same indexes, they're both separate unique and separate non-clustered, they'll just be the same.
Yeah, you can have overlapping indexes or even true duplicate indexes on the engine. The engine doesn't care. It'll let you do that. It's a waste of space and CPU while you insert and update your data. And more typing. You're welcome. As far as that goes, Blitz Index by Brent Ozar, that's a great tool for looking at a table, a place to start anyways. Missing indexes, but it'll also tell you that on this table there are indexes with duplicate key overlaps. So you could potentially evaluate and say, we don't need this index. It covers this one, so we're going to drop this duplicate, and then we save space. The fill factor for my indexes, this is how, after defragmentation or during create, how densely packed the pages are. I like to start at 90, and that's usually for a default index where it's always growing and not going to have any updates or changes that shuffle highly fragmentation. If I expect this index to become highly fragmented, I will drop the fill factor to something that I feel is reasonable, with the idea being that I won't have high fragmentation until the next defragmentation cycle runs, which we defragment our indexes every day. So I would, and it's just have to play with it, look at the data, decide how much time are you spending defragmenting the index versus letting the fill factor go lower so that you have less page density to start with. But then there's also memory constraints. You have old data and new data mixed together, and the new data is what gets highly fragmented. Then you have a huge chunk of empty pages or nearly empty pages. But disk is cheap. It's always cheap. It's cheaper to recalculate it once and then you're done with it. You don't have to calculate it anymore. Let it be empty if that's better for your. No, that's right. Okay. I can find.
It says, do you let the developers create indexes or do you have some formal approval process? I'm just curious how others handle this issue.
Okay. The answer to that question is more broad for us. I actually encourage the developers to do everything in the SQL project that they feel comfortable doing. If they feel comfortable writing their own stored procedures, their own queries, or their indexes or tables, great, more power to them. I review it all. We, the data team in my company, review everything that hits the database before it goes out. So if they do it, we review it. We gently kick back everything the same way I do internally, just with perhaps more context information wrapped around it. When I say I don't want it done this way, I want it done this way. It's more educational rather than slapping them down, because at the end of the day, I want them to do it. It saves me work. It makes them more comfortable do it, and it doesn't matter as long as the code is good. As long as I see it before it hits the server, then it's all fine. For the most part, our database is fairly static now. We're the one driving the changes. Our application is entering its end of life. But yes, I would let the developers do it as long as I review it before it hits the server. And if they don't feel comfortable, ask me, I'll do it anyways.
Do you have a set of these best practices that you have to refer to every single time you're editing? Developers come to you and ask you for the code.
We don't have everything published. Internally, I've done something very similar to this. Internally, any developers that wish to attend it, we used to call it a tech lunch, and we did it once a month or so. So I've done this type of stuff internally before, and during that, it's much more focused on the types of stuff that we do in our business. All right. The next thing that I like to consider when I'm creating indexes is whether my queries are more range driven or I'm looking for specific key values. By that I mean, am I looking for a specific entity ID, or am I looking for everything created between this date and this date? If it's a wide range, like a range value that makes sense, like the date, make that the first column on your index, and your first key column in your index. And then the system will very quickly be able to find that set and then work with it from there. If you do it in reverse and you have, for example, the entity ID first, and you're like, I want all the entity IDs where the date is in this range, the entire index must be evaluated. Index scan will happen and evaluate the whole thing, pull that out, and then go back. But if you have the date first, then it can just bracket and move from there. Another thing that we find useful in our environment is putting an index just on the primary key. For example, that extremely large table I was talking about has the primary key is the foreign key for lots of child tables. It does have lots of children, and these child tables reference it. But we found that these other tables, when they're updated, it has to check that constraint, and it's constantly going, does this value exist? Does this foreign key relationship still exist? And putting an index, a unique index, non-clustered index just on the primary key sped that up dramatically. No longer has to touch the clustered index. It can touch and worry about just the non-clustered index, which is very small, very narrow, very fast. I have gone back in some of those cases and expanded that to be a covering index just through the include columns. Just add additional columns there. So you do get a performance boost with that, especially if you're deleting data. In our environment, our cleanup process goes through and deletes data and has to work backwards up the chain, of course. Finds the children, deletes them, finds their parents, deletes them. And putting those non-clustered on those and on the foreign keys as well helps dramatically with that. You can. I would not recommend enabling it, especially not in our environment, at least. But that's what Cascade Delete was meant to do. Right. You could say Cascade Delete the parent, and then it would find all the children and wipe them out as well. But the performance was always, on large systems, was always quite terrible. Or could use some work.
I've got one more from online. I assume you use page/row compression to save space and disk. And in the buffer pool, any recommendations on the terms of when and how and so on and using compression?
Okay. Compression is something that we have looked into in our environment, and I've applied it wherever it makes sense. Our largest table, though, does not qualify for compression. Again, another downside of having all these large binary columns on it. A row must be able to be decompressed and fit on a single page. And so you cannot compress it if that's not a true statement. Our maximum row size is larger than that. So the tables where it would benefit us the most, it doesn't help. I do like compression in a lot of cases. You have these tables and it reduces how much memory they consume. You pay a small amount for CPU performance, but in this case, you're paying that CPU to get memory because that page stays compressed in memory until it's accessed, and then it'll be decompressed. So you could have an entire dictionary table, for example, our enum dictionary, compressed, and it takes up a lot less space in memory when it's accessed. So back to the question of when I would apply it, I would find your tables that you think are most accessed, and then run the, I forget the name of the procedure, but there's one that Microsoft ships where you can say estimate, compression savings, and you can say what would it look like if it was page or row, and it would give you different outputs, different compression percentages. Right. This one is fun. We use triggers in our environment everywhere. We have triggers to control our soft delete logic. We don't allow users to delete records. The flag gets flipped to delete it, soft delete basically. So we have triggers instead of triggers for create and delete operations. And then we have lots of triggers on tables that if they make a change here, we need a message to appear over here so that we can reprocess that piece of data, that information about that trip or that run. And so we have lots of triggers running in the system. And this is what I've found both on stalking Stack Exchange and through personal experience. The first defect a lot of people make mistakes on triggers is they don't make them handle multiple rows properly. Your trigger must be able to handle when multiple rows are being modified in the same statement. Some people will do it like, oh, I will always access this one row at a time, so my trigger is going to only work on one row at a time. But you have to consider that it has to work on multiple rows. Otherwise, you get inconsistent behavior. If you do modify multiple rows and your trigger only does one row, that's all that happens is one row. Another issue people use is inside the trigger, you have a couple of statements that don't exist anywhere else. One of them is where you can say update a column name, and it will return a 1 or a 0, depending on if that column was referenced in your data markup language. So if you didn't reference, the column value test, it won't fire. You can test that. So like, did the statement modify this value? It's not quite true. The update is whether you referenced it. A lot of entity framework and object relational models, when the user updates a value on a table, it updates the entire row. So it doesn't matter if you have update this or that, you're just wasting time checking that bit mask that comes through. So I usually just skip that. And instead I will use except, which I don't reference on my slide. I apologize. Except is where you can, I do, never mind. I apologize. I was up late last night polishing this. The image on the right there is how I write my statement to find new or changed rows. I list the columns that I'm interested in the top and do select from inserted, except, select from deleted. Any new or modified row will come out of that statement. I usually wrap it in a CTE and then just get it from there. And that's how I make sure that I'm only working on data when the change is what I care about. Of course, your inserted and deleted virtual tables exist in there. The table as it will be or is, depending on if you are in a before trigger or an after trigger. Before triggers are instead of, depending on how the syntax works. But inserted is the table as it is or will be, depending. Deleted is the table as it was. These are heaps. If you work with lots of data, if you modify lots of data at a time, and you take your inserted table and you join it to your deleted table, or even back to the base table to compare, you are going to have a bad time. The deleted table is a heap. It was a Stack Exchange question where they were like, why is this trigger so slow? And it turned out they were updating the entire table and then trying to find the values that changed. And it was a heap. And the engine just had to chug until it finally got through that heap, which was enormous. So in those cases, you want to work around it. You want to have, for example, in your main data load side, maybe you use the context info or session context. These are things that you can plug into session data for your current SPID. I like to call them as magic keys. So you set into your session context. So sorry, in the trigger, you have it check the session context. And you say you're looking for a specific value. For example, bypass the delete trigger would be one phrase. And it would check for that. And if it exists, then it would bypass the delete trigger. This is how we allow our data deletion process to run without disabling this trigger. But you can do this for data loads and things like that. And then you can, so say you're doing a large data modification, and you're like, it'll be faster if I disable this trigger, do my modifications, and then I take care of any after action that has to be done for this data. So you'd use the session context for that. And it's a really quick and easy thing to do. The last one is something that has vexed me, still vexes me. We use a lot of our triggers to, when this data changes, send a message to this other system, writes into another database somewhere else. We would have really liked the ability that the transaction that wrote into our base table to let that succeed. If, for example, the link server on the other end failed, doesn't exist, died, through an exception. If an exception gets thrown inside of a trigger, everything dies. There's no way to handle your way out of that. I've tried. It's just one of those things that inside of a trigger, exceptions equal doom, and you will unwind everything that happened before it. All right, just a quick check for questions. Yeah.
No, you were talking mostly, all the ones that were up there for indexes. Row store.
Mhm.
I know you said you guys migrated to cloud.
Mhm. I haven't used it. That's the reason I've not talked about Column Store. It could be beneficial for what you're doing, but like I said, our workload is so, this one day, and then we don't really care about it after that. We have a BI package that extracts all of this and shoves it into analysis services and Power BI. So we've got our analysis tools running for that. Column Store wouldn't make our transactional workload any faster. That's why I haven't used it, and so I can't speak to it.
You manage it, your team manages it.
Our team manages. Yeah, we do have a separate BI infrastructure that we run. So every night we extract from our transactional system into the cube, and then transforms and publishes data there. So, for coming from the developer world, there's a phrase they use called syntactic sugar, which things that are other things to make your lives easier by making the code simpler to read or simpler to write. We're used in the SQL world under the hood. SQL Server rewrites your queries all the time. And it's important to know some things, how it's rewriting them. Because while you may think that using a long list of n, like n and then a long list, is fairly fast, it's not. Under the hood, that turns into an enormous or clause, where it goes this value, or this value, or this value, or this value. That can tank your performance. So if you're like saying like where this is in and then select, and you have more than 100 items in that list, your performance could tank because of that. Doing an exists where exists would be faster, or perhaps a join. Join your table on the value that you're looking for instead of doing an in or an or. A unique constraint. So if you're defining your table and you just write unique after the column name, that creates a unique constraint, which is really a unique index under the hood, except that then you can't do anything cool like add included columns to it. You'd have to go in, you just drop that constraint and then create a unique non-clustered index. And then you can do the cool things and still enforce your business logic that has to be done. Common table expressions, the best way to think of them is temporary views. If you access a common table expression multiple times in the same query, for example, you're doing this and then like union alls or whatever, the logic that drives that CTE is executed multiple times. The engine doesn't run the CTE once, put it into a temp table, and then reuse it. It can't. It's doing that every time. So if you have slow performance and you're using CTEs like that, try dumping the CTE into a temp table first, and then referencing the temp table. Sometimes they are. They can be if you don't need a temp table, but you have to under the hood. What's it doing under the hood? Views, for example. Views are a relational shorthand. So you defined your view, this table, how these fields all relate to each other. But then you select from that. And let's say you select one specific column from this view. The engine takes the code for the view and plugs that into where your table is. If you look at the execution plan, and you'll see it's as if you wrote the view again or ran the view again. So that's all there. And you have the same problem with CTEs. If you reference that view multiple times, you're going to execute that code multiple times. It can slow it down considerably. It may be it may be fast enough. I have something like 20,000 batch requests per second running through my system. I can't tune everything that comes across my desk. Most of the stuff, I don't care. It runs once a minute. I don't care anymore. I care about the stuff that's running 5,000 times a minute. The stuff that takes longer than 200 milliseconds to run. The stuff that generates asynchronous I/O waits on my server. Those are the ones that I focus on and review. So I can't do all of that. But that's when you grab a query and you're like, tuning this, what's wrong with this query? That's where I start working. The next thing I like to use is, I don't know why I put this in here with the SQL Sugar, but I really like using values, the values construct there, where you can just sort of fake a table into existence real quick, just by using some quick values like that. You're welcome. I used to use values a lot to do what concat WS does. Some of the stuff is newer, like concat WS, it was with separator basically, is 2017 plus. And what it does is it lets you specify a separator value at the front and then works just like concat. Every non-null value in the list gets added into a single string and then you end it, except you don't have a trailing separator at the end. And it's much cleaner to read. So I'll use concat WS when I'm generating, I have a report, and it's a list of what's wrong with this entity. I'll use concat WS and then just a bunch of case statements to generate a description when it's this or null, when it's default, and I'll use concat WS for that. Generate series. Now, if you're on 2022, you can't use this, but it's glorious. It lets you generate, you specify a start and an end and an increment value, and then it returns a list of numbers. Here is our tally generator that we've all been having to hack together, which I'll show you my favorite way to hack it together in the next slide, I believe. But generate series replaces all of that. It's much faster and just easier in a lot of respects. String split, introduced in 2016, but 2022 forward has an optional argument at the end to return the ordinal value. So you have the order in which that element appeared in your list.
So useful.
Yes.
All the time.
Yeah.
It's a hassle.
It's incredibly useful. Unfortunately, string ag still has no unique clause, so you still have to handle that on your own. And the last one here, because this bit me, I finally found a use case to do a materialized view, where you take a view definition and you force an index so it's actually written to disk, and only to find that updating of that materialized view can block writes to the underlying tables. And that's because it has to do the code, it has to execute that code after you, if you update the value on one of the base tables, it has to be able to update that view to match it. Well, that can be a blocking operation. So you when you put that in, you need to watch for blocking. You may need to add indexes to help that process go fast enough to make the savings worthwhile. In this case, the materialized view allowed me to save, I can't remember, it was eliminate 98% of the page reads that were involved with this process. They just went away. It was this process that was checking for messages every 45 seconds or more often. And most of the time the answer was no, you don't have a message waiting for you. But let's say it took 50 logical reads to satisfy that query. Well, I got it down to 2 logical reads to check for no message. And that's incredible savings.
There's a follow-up question on the compression. It's if you have if off-row data bigger than AK, then the page row compression won't help. Any feedback on the normal cases when dealing with large tables, when page or row compression should be used, and does it make any sense?
No. So yeah, you're absolutely right. If your off-row data is larger than 8K, then you can't use it for your table. But for the cases when it's normal, I see typically like 30% improvement in compression. So I get 30% of my memory back for these tables that have huge writes. The algorithm it uses is efficient. So I've not seen any CPU spike that I can correlate directly to enabling compression. I claim back some of my buffer pool for other more deserving workloads.
How are you deciding between page and row?
I run the estimator. So I run the
Estimator.
estimator that Microsoft provides, and I just pick the one that it says gives me better compression. Typically, it's row. typically row gives me better.
I work with a vendor product and they choose page. They want everything to have page.
If you work for a vendor product, that's it's just what it is. There we go. So here is my favorite way of generating a series of data, a numeric series. So instead of having generate series, I actually had a function that ran this code. You essentially run the same way that the series did, except it didn't have an increment. I said, like, just give it a start and an end value, and it will give you back a list of numbers. This is fairly compact, very efficient code. If you add, in my use case, I actually had to add an additional layer, like an L6 for my cross join. As it is now, it'll give you 4 billion numbers. That should be enough for everybody. It was not enough in my use case. I had to go to the next one, which gives you up to 18 quintillion. I didn't need 18 quintillion. I just needed more than 4 billion for my numbers. Next one is a bug that bit my BI department. They were doing an import, and the import failed on them, and they did not understand. They could not find out why. So I had to investigate, and I was eventually able to find the row that was breaking their import system. But what their import did was found the Monday for the prior to the input date, which is great. We all use this formula here. This is what Microsoft gives us, unless you have a date table. Speaking of which, go build a date table. But so you do date add week, date diff, week 0, get date 0. What is this doing? So if you have a 0 in there where you're saying like date diff week 0 to get date, it sees the 0 and it converts that to the start of the epoch for a date time value. As a result, the data type is date time. If your get date is, for example, a date time 2 column that has an epoch of 0000-101, which is well outside the boundaries for a date time, you get a date time constraint, data type violation, because you can't coerce the zeros into a date time value. However, if you take that 0 and replace it with literally cast 0 as date time, you get the same value back, except the date diff function is able to see that your right-hand value is a date time 2, and will let you coerce the entire operation into a date time 2. And then it'll work, or at least not blow up on you, which is what we really wanted. It was just a really weird thing that I saw there. So now in my code, and I've encouraged our BI guys to do that, anytime I see that math, I take the 0 and just replace it with an explicit cast to date time, and then future-proof for handling bad data, which really at date time should be enough for everybody, but it's not. This last one comes from a puzzle that Brent Ozar did. Sorry, mouse is backwards. There we go. I want everybody to look at this and tell me what R2 will be equal to. Think about that. What will R2 be equal to? You can see I start by setting R1 to where ID is 1, and then R2 is where ID is 2, so it should say value 2. And then I say set R2 again to where the ID is 5, but there is no 5.
Too bright.
Too bright? I apologize. But the answer is it keeps the value. It keeps the value. Selecting your values like that, I would consider that a bad practice. Instead, what you want to do is do set like that. Same operation, except it properly says no, which is what we expected, because we said, what is this value equal to where it's 5? Well, it's null. You get the same behavior if you're doing that select inside of, for example, a loop, where you're looping over a set of data, and you do that select to get the value from that. If your incoming value is null, it doesn't override what the prior value was. So you can have bad data inside your loops. All right. There we go. The next thing we see a lot is queues in SQL Server, trying to treat SQL Server like a messaging engine. And rule 1 is don't do this. Don't write data into SQL and then attempt to update it and then attempt to delete it or do anything with it. Especially don't do it if your system is generating over 5,000 messages per minute. But I'm doing a presentation later this year about how to do it effectively. So if you're interested in how to do it anyways, come check it out. But don't do it. Use something better. Service bus. There's something cool coming down the pipe for I think everybody. They're going to integrate a call to service bus directly into SQL Server. No need to roll your own with a was it cross domain library, cross code, whatever. That I'm really looking forward to just using that, because then I don't have to do this anymore. Has anybody here used query hints in their queries? Everybody's heard the advice to stay far away from them. Don't do them. Don't use them if you can help it. And it's good advice. If you don't know what these do, I wouldn't start writing a query that uses hints like this. But sometimes you need to give hints to the engine to help it make better choices with what it's doing. So these are some of the more common hints that I've used. And I have used them, and I've used them effectively and correctly, except no lock. I don't like no lock. Definitely don't release production code with no lock. It allows you to have dirty reads at the best of cases. And it doesn't really take no locks, but it's really great sometimes. It makes the query go, which is all you really need. But using no lock is usually a hint that there's something else going on. And maybe you can't fix that something else, but you should always be cautious with using the no lock. The next hint I've used is updlock and xlock, which is where you've indicated to the engine that you're going to take you want to take an exclusive because you want to delete the row, or you're taking an update so you can update it. Where I've used this the most is actually doing queues in SQL Server, where you really want to hint the engine, listen, I'm taking an update lock, not an xlock. Please don't block anybody else. Please don't escalate to a different lock type. And with row lock, you're saying, I really, really, really want this to stay at a row lock instead of escalating to a page or a table lock, just to help the engine make better choices. Hold lock tells it that I want you to hold this lock. For example, you can select and specify an update lock. Let's say you're testing to see if a record exists or if the record has an old value before you try and do an update. So you select against the base table, and you're like, I don't want to select and then do an update and then test, because what if the data changes on me underneath? Data changes under me, and I don't want anybody else to come in and see the old value. So when you do your select, you tell it update lock, row lock to, again, constrain the engine, and then hold lock to say, I want to hold this until I'm done with my entire batch. So you start with your select, and you take your locks if they're valid. And then you finish your work, and you don't need to take a lock again. Because what if you select the old value, somebody comes in, grabs it, just to bypass all of that. I still recommend hold lock if you're doing the merge statement, by the way. So if you're doing merge into, I recommend hold lock still. The next hint that I've used is read past. Again, in queuing, this is where it's the most benefit to me. But read past will let you say, find me the next message that needs to be worked on. And if it's already locked, bypass that, because you're multi-threaded your dequeue. So you're going to pass in the option to read past, so you ignore any other locks, as opposed to the engine trying to wait for a lock to clear. Another thing that I use quite a bit is the lock timeout. So you set lock timeout at the start of your batch, and you say a reasonable number of milliseconds. Call it 5,000 milliseconds or 250, whatever is reasonable for your environment. If the next statement or any statement in your batch can't achieve its locks within that time frame, it exits. This is great for everybody having those little jobs that run every 10 minutes, every 5 minutes, and it has to find records that meet some criteria and fix them for the application, because they can't go back and change the application. But you don't necessarily need this to work this time. It's okay. You want this one to die if it needs to die. You don't want it to try and wait for a big update to finish, and then all these other tiny requests come in and wait behind it. You've seen these lock chains in the system. So with this lock timeout set, you can say, like, if you can't get your lock in 5 seconds, I want you to give up, go away. We'll try again next time. And then it lets all these little ones that were stacked behind it after 5 seconds, now they get to go. And they work, and they do their work as they need to. You'll see the same thing with the lock timeout with index rebuilds. If you use Ola Hollengren's scripts to do your index maintenance, he's using that under the hood to, if it can't get the lock to rebuild the index within such a period of time, just give up. Try again, or move on to your next task. Better to get something done than nothing done. Max DOP, I've mentioned that before with queries. I'll usually set to max DOP to 1. I want to make sure that the query goes single threaded. A lot of times, especially in my environment, if I see a query going parallel, it's not the best choice. It's doing that because it's trying to do giant table scans against my big base tables, which are not great. Sometimes setting max DOP to 1 fixes that. At least stops it from being so memory hungry. Sometimes I'll need to specify a specific index is used. So I'll use an index hint there. Or at least my best practice for that is in my source control. If I have a query that uses an index hint specifically, wherever that index is defined in source control, I'll add a comment just above it saying this is used in reference the query or the stored procedure, so that people know that they're going and modifying that index, that they need to take care. Of course, force seek and force scan do what they say on the tin. You're preventing the engine from making its own choices. If you need to make sure that it uses a seek instead of a scan. With high memory pressure, we sometimes see large query, the plan cache is under pressure as well. And so we'll sometimes see good plans kicked out and replaced with potentially bad plans. So sometimes we'll go in and add little hints for these ones that get kicked out often, because they only run every 10 minutes instead of every minute, for example. So we'll add these little hints throughout the engine. This is getting better. I believe Query Store 2022, or maybe the next version, has a feature where it will actually remember you can give it plan guides inside Query Store to guide queries properly, instead of having to go through and hint or put the plan guide inside the query. And then finally, no expand. And I referenced this one just because I have used it. If you're going to use a materialized view, as I did, you might as well go all out, specify the no expand hint, which tells the engine, don't attempt to rewrite the view, because again, that view just gets subbed in for your name of your view, but I'm like, I don't want you to attempt to rewrite it, use it as you find it. And then you specify the index as well. So might as well, to prevent the engine from making bad choices. The question in the comment about using column store indexes in my environment, I have not. I just have not had a chance to use them yet, so I have no comment on them. I do know that they're out there, and I know that they can make certain things really fast. I encourage you to try and experiment with them if you can. If you hear a feature that might solve your problem, give it a shot.
So you're talking about a lot of things. Normally, I mean, we try to write a lot that's slightly different, saying transaction isolation, read outcome. So it's doing a dirty read still. In our case, we don't even need that. Our system is locked during the ETL process. Rest of the time we use it. Normally, the automatic has it usually not locked or locked. So, in the cases that there is some other system that's reading a transactional system like this, let's say your warehouse team reads out of your transactional system, what would be a scenario when they would have to read it right after the ETL process every 45 seconds gets done? Instead, what would be the downside for them to wait for that 45 seconds, or in their scenario say we have to read that? It's going to update anyways the second time it sees it.
Right.
It's actually in the transaction.
So the question was about the interactions between using the no-lock query hint and the BI team reading the transactional data into their cube. Our workload is heavily dependent on time of day. We don't transport children at night. It's good for us. So we have a large window daily to do our work. So that's when our BI extraction happens. If that was not the case, and I've worked in places that did this, what I would recommend is to use, what's the feature called? Database snapshot. I would prefer to create a database snapshot and have the BI team use the snapshot to read. Because when you create the snapshot, you create a consistent point in time for all of the data, not just the one table, the transaction. See the whole data, have the BI team read from the snapshot, so they get a consistent piece of data when they're doing their reads, and then drop the snapshot after they're done. And then you don't have to worry about no-lock hints or anything like that.
So possibly daily snapshot there for 18 keys if you wanted sooner than that, 6 hours, 12 hours.
Yeah, start it, you say create snapshot, which you want to make sure that's coordinated to get not during the same time that your index maintenance is, because the snapshot's log file will start accumulating the delta between when you create it and when you end, and when you stop using it. So if you're doing a large index maintenance work, then your snapshot file is going to grow enormously, and it's probably not what you want. So remember to make sure that's not happening. But yeah, you can create the snapshot or incorporate the BI team's work, and if you can afford it, into your testing your backups. So like every day, we're going to restore to this server over here a copy of last night's data. We're going to transactionally roll it up to the time of X. We're going to turn it on and then let the BI team read from it. Read from that. They get a transactionally consistent data, and you have tested your backups, which everybody should be doing. Sure.
It's How's your experience been with managed instance? Are you affected by unplanned outages or maintenance performed by Microsoft? And do you use any HA features with the managed instance?
So the question about managed instances. The experience has been overwhelmingly positive, which is not to say that we have not been aggravated by Microsoft's shenanigans under the hood. We are using some of their high availability features. We have a failover cluster defined. We have one node in central and one node in east. And we fail back and forth fairly regularly as part of our regular testing for that. That said, the issues that we've had sometimes, it's like they get a stuck update on the underlying computational nodes. So we'll have our, for example, our east node just start power cycling. I can tell it's power cycling because I can read it in the sys, one of the dynamic management views tells me the last server start time, and it starts power cycling. To our users, it looks like it's slow because they have retry logic built into the application. But to our side, it looks like it's restarting. And that's because it's trying to update, and it fails, and updates and fails, and updates and fails. So when that happens, we fail over to the other side, as it were, and that usually bypasses the issue. It's happened 2 or 3 times in the last 3 years, so not unheard of. It's something you have to be aware of when you're in the cloud, that you don't control the infrastructure anymore. The other thing that has hit us has been full text indexing. Sometimes the daemon just appears to die. This happens about the same, not related to that time, but about the same. It's happened about 2 or 3 times in the last 3 years or so. And when that happens, because I can't open up sys.processes and just restart the full text daemon, I have to fail over to effectively do the restart. But otherwise, managed instances has been great. No problems there. So, what smells with your queries? When I'm looking at a query, I'm trying to evaluate what can I do to effectively fix this query. I've decided that it needs attention. So I'll look for functions. I'll look for date math. I'll make sure that the arguments are sargeable. What I mean by that, of course, is that the search arguments can use an index, and that's pretty much directly related to date math. If you're doing date math on the column and then comparing that to a static value like the current time, you're going to have performance problems because you can't use the index anymore. You make sure you're using your date math on the static value instead. Sometimes you can't get away with it, but that's one of the places I see large in or lists. Table hints, I know I was just talking about using them, but it is a code smell. You see a table hint, you should evaluate why is it there? Is it still necessary? The engine changes quite a bit. If you've changed versions especially, you need to reevaluate your use of hints. If I see a distinct or a group or an order by, you don't need to order the data in SQL Server. Let the client do it. It's faster at it. And again, you're not using that expensive CPU to sort. Usually distinct and group by is someone writing a query, not understanding when they do the joins, which one will give them more rows than they expected. You can sometimes get away with that by doing the distinct there or just fixing your query so that you don't get duplicate rows. And then, of course, select star. On the right, when I'm tuning queries, I usually set statistics IO and time on. I then focus almost exclusively on logical reads and execution time. 99.9, 6/9 of the time, if I rewrite the query to get logical reads to the minimum value, Everything else about the query has improved as a result of that. The time it takes, everything has improved. There has been one case where that was not true. And I picked the one that had the lowest logical reads, even though it consistently took 15 milliseconds longer to run. And that's because logical reads directly impacts how much memory is required to run the query, as well as how much memory the system will try and load in the buffer pool to service that query. So reducing logical reads affects my buffer pool, which is how much memory I need, which is my most precious resource on my environment. So in that case, I picked it. The difference was slight. The query didn't need to be that lightning fast. 15 milliseconds is an eternity in the engine. And so I chose the one with the better logical reads. Sometimes when you have a query, you take two massive tables and you're joining them together. You're like, I need the data from here and I need the data from here. That makes the engine go kind of crazy. On my environment, I know which tables do it. I've worked with them enough. I know that you just don't join them. Instead, you run one query first to look up your list of keys. Like, I'm going to look in this one, find all of the keys for this day, and we'll store that into a temp table or a table variable. And then I will join my big tables on that key list. And that it keeps it from doing a table scan, because the engine knows that it can get there by using that key list if it uses the right indexes. But joining them, just the engine goes kind of crazy. And then the last bit of advice for this is, if you're using coalesce or isNull, what's the data type for the right-hand parameter? You do isNull, column, and then a default value. If the data types are not kosher, then it will it'll just error out on you. You'll get a data type violation. You don't know quite where in your query you get it, because you're just doing a select. How did I get a data type violation? Well, it's because you selected a varchar column, but you gave a default value of an integer, because you're storing numbers there most of the time. So the first time the engine encounters a value for that column that you've done an isNull on, it uses that data type for the default. If the first row is null, it used the integer and said that value must be an integer, and then try to coerce your text column into an integer, which only works 99% of the time.
Just a quick question. Alex is asking if you have a recommendation on a particular book or training course or on query tuning. I know Pluralsight has some courses online.
As far as reference materials, there is a book, T-SQL, I think Itzhak Ben-Gan wrote it. T-SQL querying has been great, or is great. Otherwise, it's just been raw experience, and attending events like this. People give presentations explicitly on query tuning, has given me all the insights for that. So link servers are a necessary evil. If you have a query server over here, you need to write or read data from a server over there. A link server may be the only way to do that. You do need to be aware of the security implications of doing that. A lot of people use a login, and then they don't properly restrict the login in the other server. So if you take your worst case scenario, and the domain account running your SQL Server instance is a domain administrator, and your link server, the account used for a link server, is a sysadmin on your other server. Any user that knows how to properly construct a series of nested strings could potentially gain domain access in your environment. You do that by connecting as a low-level user to server A, and you craft your poison query that goes across to server B that opens up a command shell using your sysadmin account on server B, and that command shell opens up as domain admin, and then you've got magic happening. That's a lot of environments that's going to be caught, and that's not going to be possible anymore. But one of the first places I worked, that was what they did. So in security, just make sure, just check everything. All the layers need to be verified that are running the least possible permissions, but especially that the server, the account used to access server B has the minimum number of permissions, and definitely shouldn't be able to open up anything like command shell. As far as the performance goes, unless you're doing very specific queries, you're like, I want this one piece of data, a lot of times the engine just gives up. So you're asking server A, show me the data from your local tables, and then join on this table from server B. The engine on server A is the one trying to satisfy your query, but it can't talk to server B about what the data looks like or really anything. And so it just give me the entire contents of that table, please. I'm going to pull it over to a local cache, and then I'm going to process your query and then give you your data. So for the most part, I recommend if you're using linked servers and you're pulling data across, develop a list of keys, a short version. Even if you're saying like, just give me everything for today, and you pull that across as one pull from server B, and then you into a temp table, and then you use that on server A. That's going to end up being much faster. My preferred format for using linked servers is as you see on the screen here. I use the execute text string at remote server name. That lets me do dynamic SQL, so I can build up my strings dynamically. It even accepts arguments. It does accept them in the positional sense, where it's a question mark. So if you have more than one, then you'd have another question mark. You need to specify your arguments in the same order of which they need to be applied as the question marks. But this is my preferred syntax for accessing remote servers. The worst case that I've seen was a server A referenced a view on server B, which referenced something back on server A, which then went to server C. So this was an enormously, I caught this in action once, and I went to my boss and was like, we got to do something. That was not great. We weren't able to fix it. We just had to live with it. Unfortunately, one of those legacy apps that just sits there. And onto security. I keep SIDs the same for every login between my environments. So I have my production environment, my QA, my UAT, my developer environments. So the SID for the application user is the same on all of them. So when I restore from production to UAT, I don't have to worry about permissions.
Okay, hold on that. So you're using the same account. So aren't you concerned that somebody's going to get in and think that they're pointing to the QA system with that account, yet it's pointing to production and they accidentally have a boo-boo?
That's possible. The passwords are different. Of course, the passwords are different. We're using SQL logins, not Active Directory logins. If it was Active Directory, it would be, I would argue, the other case, what you've described, where you have different users for each one. Additionally, the developers do have full permissions in their lower environments to do anything they want. But in production, they are not. They are very much restricted.
So you have the SID the same, but you have separate passwords. It's the same account, same SID, but different passwords for the environment.
Yes, the passwords are all different. You have to know and try with the production password, which wouldn't work in your lower environments. But I keep the SID the same. It makes restores much easier when you're dropping a database from lower environments. I use XP login info. You can pass in Active Directory groups and get back a list of group members from that, which is great for DBA trying. You don't have to go to the security team to ask them who the members of this group are. You can just ask XP login info, and it'll tell you. It doesn't even need to be a member that has permission, has access to your SQL Server. That's directly queries Active Directory, and then comes back to you. You can, and I have used it to digest the Active Directory infrastructure and give reports back to the user, back to IT management. Basically, they asked for things that the security team wasn't able to give them, but I was able to from what I had here. So my word of advice, if you're going to do this and digest your Active Directory, is to make sure you avoid circular references, because Active Directory will allow circular references, a group to be a member of another group, and that infinitely circle. So you need to watch out for that when you're writing your code. Finally, I use groups and roles for as much as I can. And I do this in our source control system. I will create the role in source control, and then I will grant permissions to that role also in source control. And what this does is anytime there's a deployment made, it fixes anything that anybody may have done in the meantime. It will revert it back to whatever it was in source control. And then members, of course, are just added in Management Studio. So that doesn't exist anywhere else except SQL Server, the membership of those roles. But what those roles can do is controlled through source control or maintained. This is the benefits of going to SQL Saturdays and things, as I saw somebody with this. And this was awesome. This is map mode for your vertical scroll toolbar. And you get to it just by right-clicking on it and selecting scroll options, and then map mode. There you go. Then you get this nice scrollable bar on the right-hand side where you can just scroll up and down. Yeah. I think this is enabled by default in Visual Studio if you do code, but Management Studio does not. But it's based on the same engine, so it's there. It's just all right. The other thing is you can add line numbers. If you're constantly right-clicking on objects and say script this object to a new window like a table, so you want to see the table definition, if you go to Tools, Options, SQL Server Object Explorer, and Scripting, you can change the default options for that. So you can say like always include indexes, and then you will always get the indexes as part of your script out command. So you can do whatever changes you make there will change the defaults. That also changes the defaults when you right-click on an entire database and you say generate scripts and generate objects that way. But if you're doing individual objects, I like tweaking that because I want my indexes to appear there. That's one of the reasons I do the scripting like that. Another thing I like to do is Alt F1, which gives you this lovely not diagnostic, but top level view of the table. You get the columns, you get primary keys, you get indexes, you get a bunch of other stuff. You just highlight the table name and hit Alt F1. Another useful function is DM exec describe first result set. It doesn't like temp tables, but it returns an output like this. So you give it a table name or a stored procedure or a query even, and it will give you all the columns, their data types, and things like that. and I've used it before. I've used it to compare two stored procedures that had huge column lists to make sure they were returning the same values. You just join them together on the ordinal position, and then where the column's not the same, column name's not the same, or the data type's not the same. I used to have an enormous script that would do the same or similar thing, and it was always a pain to use, but this is much nicer. It doesn't like temp tables though, so if your store procedure uses temp tables, you're going to have to fiddle a little bit to get it to go. When I work with temp tables, this is how I like to structure them. I create my temp tables. I do indexes in line with my definition like this. This is the recommended method. The downside to doing them, actually doing the indexes at all on temp tables, is that if you have a script you're running where you're like, I'm going to create this temp table, I'm going to drop it first, then create it, then populate it, and you want to run that script again, you have to drop your indexes explicitly. It's easy enough, just make sure you reference them all. Otherwise, you get a compile time error. And this is the last one. This is a list of my favorite tools that I use day to day. I love using PowerSQL as a online free code formatter. I know we don't all get to have Redgate, which does a better job ostensibly, but this is free. And it does have plugins available for just about everything you can think of. Statistics parser is one I use even more often. This is how I take that huge output that you get from turning on set statistics on in time. You take that, you paste it in here, and it will format it nicely, and at the very bottom summarize all of the data for you. So you just scroll to the bottom and you can count the logical reads used by the entire batch, not just a statement, but the whole batch. And you can use that to say like, oh, it's doing scans on this table, so I'm going to go to this table. Where am I using this table? And try and just tune that one specific part. Because a lot of the queries I work with are enormous, and their execution plans are similarly enormous. So speaking of execution plans, SolarWinds Plan Explorer, which is not here, not listed, I believe it's still free, is wonderful for that. You take that plan, you put it in there, and then you can sort the operators. You can say, find me the most expensive operator, which is where to focus on. Notepad++, free text editor, lots of plugins. I like using the XML plugin myself, so I can pretty up XML to make it easier to find. I use Database Performance Analyzer every day in my job. That's by SolarWinds. Really helpful for finding those queries that need to be tuned, either because they're spending too much time in a particular wait state, like async IO, or their execution time is taking too long, or lots of blocking. But it makes it really easy to find the ones that need to be tuned. And then, of course, DBA tools is just a collection of PowerShell modules, which is great for managing your SQL Server.
Hey, Jonathan, do you have alerts set up with your DPA so that if there's like excessive, if they're blocking over a certain amount of time, you get an email or text message or things like that?
You have the option to turn it on. We've not turned that on. We have different tools we use for that level of monitoring. But it does have capability for that. That's the end. Does anybody have any questions?
Oh, just a thanks. Yeah, thanks, Vesham. Yeah, this excellent lecture. Was being recorded, and I will get that up to our YouTube channel. So you'll be able to just Google over on YouTube and find us, and I'll get that presentation up as soon as I can. Really wanted to thank Jonathan for an excellent presentation. It just gets us things that we can start looking into and start using. And that Iksak Bengan book is very, very good. Yeah.
Yeah, I do
Useful.
recommend it if you want to learn how the engine thinks or how the engine works.
I'm going to stop the recording.